In this example, we'll look at a trig substitution where the radicand, the stuff under the radical, is not the form that we're used to in the previous videos. Let's force it to look like something that we're used to. So let's start with that radicand. We'll just copy that quadratic off to the side. And what we want to do is we want to complete the square on this quadratic. So in algebra class back in the day, you started by moving the constant. Now in algebra we had an equation and we would subtract the 5 on both sides. We don't have an equation in this case, so let's just move that constant off to the side a little bit. And our goal is to put a number here so that we get a perfect square trinomial. To do that, we use b divided by 2 squared. In this case, b is 2. We have 2 divided by 2 squared. That is 1 squared, which is 1. So we add the 1 beside the 2x. And again, back in algebra class, you would then add the 1 to the right side of the equation to balance it out. But since we don't have an equation this time, we need to undo what we just did. If we added 1, we need to then subtract 1. We'll just do it off to the side. And now we have created a perfect square trinomial, which can be factored as x plus b quantity squared, which in this case, if we factor that, we get x plus 1 quantity squared, and then we'll bring down the 5 minus 1, which is 4. We can now rewrite the original integral. We'll get dx divided by the square root of, let's replace that quadratic with what we have here, x plus 1 squared plus 4. Now the stuff under the radical, that radicand, looks a little more like the form that we saw in previous videos for trig sub. We can now do a U-substitution. U will let be x plus 1. Then du is equal to dx. Rewriting the original integral, we have du now divided by x plus 1 is now u squared plus 4. All of that is still under the radical. Now it looks much closer to what we saw in previous videos. We have a variable squared plus a constant squared. Here the constant would be 2 squared. All of that under the radical. Now we can do the trig substitution. This time let's let u be 2 tangent theta. Du is then 2 secant squared theta d theta. Going back to that integral, we're going to replace du with 2 secant squared theta, and I like to pull d theta out to the end. In the denominator, we have the square root of u, which we are calling 2 tangent theta, that is squared, plus 4. Let's now focus on cleaning up that denominator a little bit. We'll just copy the top for now. The denominator, under the radical, we have 4 tangent squared theta plus 4. Remember, the goal at this point is to get a perfect square under the radical. Just copy the numerator. We can factor 4 out of the denominator, leaving us with tangent squared theta plus 1 d theta. At this point, tangent squared theta plus 1, hopefully we recognize that as one of our identities. Copy the top. In the denominator, we have the square root of 4. Replace tangent squared theta plus 1 with the identity secant squared theta. Next, we'll simplify the denominator a bit. Again, just copying the top. The square root of 4 is 2. The square root of secant squared theta is secant theta. D theta off to the side. Now we can reduce a tiny bits. 2's will go away. 1 factor of secant will go away, leaving us with the integral of secant theta d theta. Now we can actually integrate. The integral of secant theta is the natural log of the absolute value of secant theta plus tangent theta plus c. At this point, we're almost finished, but notice our variable is in terms of theta and the original integral is in terms of x. So we need to put this back in terms of x. We'll have to be careful here because we did 2 substitutions. One of the things we said was u is equal to 2 tangent theta. Let's use this idea along with SOHCAHTOA from trig class to help us set up a triangle. We'll start by dividing by 2. U divided by 2 is tangent theta. And then prior to that, one of the first things we said is u is x plus 1. So we now have x plus 1 divided by 2 is tangent theta. We can now use that to help us set up the triangle. Theta is here, and again, trig class, SOHCAHTOA. Tangent, remember, is opposite over adjacent. So if we're looking at angle theta, the opposite side would be x plus 1. The adjacent side would then be 2. We need to then find this hypotenuse. We can then use the Pythagorean theorem to find that missing side, the hypotenuse. That is x plus 1 squared plus 2 squared, which is 4. This is our hypotenuse. Finally, we'll go back to the natural log of secant theta. Remember, secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. That is x plus 1 squared plus 4 divided by the adjacent side, 2. And now tangent theta. Tangent is opposite over adjacent. So the opposite, x plus 1, over the adjacent, 2. Close the abs val, and plus c. Lots of tedious steps, but we finally have the value of the integral.